We've seen the Earth's obvious geothermal clues, the dramatic signs that tell us heat is leaking to the surface. But how do we move from spotting a hot spring to building a multi-million-dollar power plant? We start acting like detectives, piecing together evidence using a series of non-invasive techniques to see what's happening miles below our feet without drilling a single inch. This is surface exploration. The investigation begins with geological surveys. Geologists are like historians, reading the story of the Earth written in the rocks. They create detailed maps of the area, identifying the types of rocks at the surface and, crucially, mapping the location of faults and fractures. In geothermal exploration, these faults are incredibly important. They can act as superhighways, providing the pathways for hot water to travel up from a deep heat source towards the surface. Next, the detective team brings in the forensics, geochemistry. Scientists collect samples of water and gas from those surface manifestations. This water has been on a long journey from deep within the earth, and it carries a chemical fingerprint of its origins. As it travels through hot rock, it dissolves minerals. By analyzing the concentration of specific elements, like silica and chloride, we can use chemical formulas called geothermometers to calculate the temperature of the reservoir it came from. It's a clever way to take a temperature of an engine you can't see. The final step is to create an image of the underground structure using geophysics. One key technique is a resistivity survey. We pass a weak electrical current through the ground and measure how much the subsurface rocks resist it. Hot, salty geothermal water is an excellent conductor of electricity. It has low resistivity. So, by mapping these low resistivity zones, we can often pinpoint the location of a potential reservoir and the conductive clay caprock, trapping the heat above it. At the same time, we use seismic surveying to map the plumbing. By creating small, controlled vibrations at the surface, we can listen to the echoes as they bounce off of different rock layers and faults deep underground. This allows us to build a 3D map of the subsurface architecture, confirming the structures we identified in the geological survey. Geology, geochemistry, and geophysics. None of these techniques give us the final answer alone, but when layered together, they allow us to build a detailed 3D model of the subsurface. This model is our treasure map. It dramatically reduces risk and uncertainty, allowing us to pinpoint the most promising targets for the next most critical phase of exploration, confirming the heat with drilling.